Welcome to The Explainer. Today, we're diving into something pretty amazing: how machines are learning to understand, model, and even generate human language. Okay, let's get right into it and see how a computer can start to make sense of something as complex and, as human as our own language. So here's the plan. We'll kick things off with the basics of natural language processing. Then take a look at a common, but kind of flawed way to visualize text. From there, we'll build up our understanding from simple word pairs all the way to the formal rules of grammar. All right, so first things first, before we get into all the nitty-gritty details, let's just tackle the big, fundamental question at the heart of all this. Right? I mean, think about it. Computers are amazing with structured data, stuff that fits perfectly into databases, rows and columns. But language is messy, it's ambiguous, it's full of nuance. So where do you even begin to get a machine to process it?
Well, that's where this whole field comes in. It's called natural language processing, or you'll usually just hear NLP. And its entire purpose is to build that bridge between the beautiful chaos of human language and the strict logic of a computer.
And you use it all the time, probably without even thinking about it. It's the spam filter that keeps your inbox from overflowing. It's the predictive text on your phone that feels like it's reading your mind. And it's the virtual assistant you ask for the weather. See, the goal is to get the machine to process the language, not just, store it as a block of text. Okay, so let's say we've got a huge pile of text. What's the simplest way to get a computer to see what's in there? I'm pretty sure you've all seen those word clouds popping up everywhere. They seem to be the go-to first step for a lot of people.
And a word cloud is, well, it's exactly what it sounds like. It's a simple, pretty artistic way to see which words show up the most. It just counts everything up, and the words that appear more often, it makes them bigger. It's a quick, at-a-glance summary.
But here's the thing. Yeah, it looks cool, but what is it actually telling us? The way the words are scattered around is totally random, isn't it? So does it really give us any deep insight, or just tell us which words are the most common? And you've just nailed its biggest weakness. Honestly, most data scientists really aren't big fans of word clouds because that layout doesn't mean a thing. A much, much better way to do it is with something like a scatter plot. See, here the axes actually mean something. For instance, we could plot how often a word shows up in job postings on one axis and how often it shows up on resumes on the other. Now that starts to show us real relationships, real insights, instead of just, big words. Okay, so just counting words isn't going to get us very far. Language is way more than just a big old bag of words, right? The order, the sequence, that's where the meaning is. So how do we start to model that? That's a great question, and the answer is something called n-grams. So instead of only looking at single words, which we call unigrams, we start looking at them in sequence. We can look at pairs of words, which we call bigrams, or even little groups of three, which we call trigrams. This is how we begin to understand context. A big-gram model is actually pretty straightforward. It works by learning probabilities. It looks at a massive amount of text, and after seeing the word data thousands and thousands of times, it starts to figure out which words are most likely to pop up right after it. It learns that science often follows data, but something like book probably doesn't. This is our very first real step toward modeling context. So hold on. If a model can predict which word is likely to come next, does that mean it can actually write a sentence all by itself? It can definitely try, and this is where it gets really fun. Take a look at this sentence here, generated by a simple big-gram model. Well, let's call it grammatically creative. All the right words are kinda in there, but there's no real structure, no long-term plan. It's just jumping from one likely word to the next. But check out the difference when we upgrade to a trigram model. Because it's using a two-word context to predict the next word, the sentences suddenly get a whole lot more coherent. The model has more information to work with, which lets it create phrases that are not just longer, but actually sound way more plausible. It's a huge leap forward. Okay, that is a massive improvement. But at the end of the day, it's still just playing a game of probability, just chaining words together. What about the real rules of language? Actual sentence structure. Absolutely. And to get that kind of deep structure, we have to move past just statistics. We have to start teaching the machine the actual rules of the game. And we do that using something called formal grammars. So instead of just probabilities, a grammar gives the machine a hard set of rules. For example, a core rule might be a valid sentence, we'll call it S,
is always made of a noun phrase, NP, followed by a verb phrase, VP. And then each of those parts can be broken down even further into nouns, verbs, adjectives, and so on. And by following these rules step by step and plugging in words from our vocabulary list, we can generate sentences that are guaranteed to be grammatically correct, at least according to the rules we gave it. This is the crucial leap, right? We've gone from statistically guessing the next word to systematically building a valid sentence from a blueprint. And that progression is really the whole story here. We've journeyed from just counting words to understanding their sequence, and then finally to actually defining the structural rules that hold the language together. That journey is absolutely fascinating, isn't it? But it leaves us with one final, big question. We've managed to give the machine a rulebook for grammar and syntax, but the next great frontier, the real challenge, is teaching it how to understand the story, the context, the meaning behind all those perfectly structured words. If you found this explainer helpful, we'd really appreciate it if you'd like, share, and subscribe for more. Thanks so much for watching.